Hi, I'm Wes McCall with Geoprobe Systems. I'm a geologist. Today, I'm going to talk to you about using prepacked screens to construct groundwater monitoring wells. The prepacked screens are nice to use because they're simple and efficient to install. They're good for monitoring groundwater quality at most any environmental site, such as underground storage tanks, or possibly where you have dense non-aqueous phase liquids, DNAPLs, such as TCE or PCE. The direct push method is used primarily to install wells in unconsolidated materials such as silts, clays, sands, or gravels. We've worked with the ASTM D18 committee to develop and have a ASTM standard practice for direct push installation of prepacked screen monitoring wells. That standard number is D6725, I believe, and is published and available on the ASTM website.
I'm Nathan Lee. I'm going to talk a little bit about the different products available for prepacked screen monitoring wells. There's 4 basic sizes that we offer, and that's based on the PVC size. And the smallest one's a half-inch, has a half-inch piece of PVC in the middle of it. And these are made for installation in 2 1/8-inch probe rod. Then also there's a 3/4-inch PVC, which is a little bit bigger diameter, and it's also made for installation through the same rod. The next size up, we've got a 1-inch prepacks, and it has a piece of 1-inch slotted PVC pipe in it. And these are made for installing in the 3 1/4-inch probe rod. And then also we have a 1.5-inch prepack. We also have the riser pipe that goes in the top of the prepacks, and there's available also in 1/2-inch, 3/4, 1-inch, and the largest is 1.5 inches.
Before we go on and do this, I'd like to say 2 or 3 things that I think are kind of important. 2 primary objectives for installing wells is 1, protect the groundwater quality, and number 2 is being able to obtain representative water quality samples. And then to be able to achieve those, the third thing is decontamination of equipment between sampling and installation locations. What we have here is an expendable point holder, and we're going to take the anchor point with an O-ring to seal it up, and we're going to simply install that in here, and then we'll set up and advance this into the subsurface, and this will close the drive string as we advance to depth, and then this expendable anchor point will be used to help anchor the screen in the formation. And also what's good to do is after you add each probe rod is to snug the whole rod string with the wrench. That way you make sure all the joints stay tight and you don't have any material coming in anywhere that you don't want to happen. Again, integrity. There's a scale on the side of the probe mast here so you can see what depth you're at, and we've advanced it till we have 2 feet of rod remaining above the ground surface. We're at the depth we want to be. So now we'll set up to install the screen. Nathan is going to go ahead and install the snap lock connector on the bottom of the screen. This will latch on to the top of the anchor point, which kind of has a mushroom-like fitting on it. It'll latch on there and hold the screen in position. We're simply going to assemble the screen now. We got the snap lock connector on, assembling the screen, and we'll start lowering it in place. We have O-rings on each casing joint just to make sure that you have high integrity, that the water that you're sampling is from the interval that you want to sample, and again that you prevent cross-contamination. The screen is down just above the anchor point, so what you do is once you get it over the anchor point is you bump the snap lock connector into place, okay? And then you can pull up on it and you can see that you're anchored in position. We use just one 3-foot screen section, and if you want longer screen intervals, those screen sections can be simply threaded together. So if you want a 3-foot, 6, 9-foot screen interval, or a 5, 10, 15-foot screen interval, you can do that. I usually try to encourage people to use shorter screen lengths when possible so that you sample from a well-defined zone. Next, what we'll do is we'll trim the PVC, and we'll just put a poly cap to seal the top of the well temporarily as we do the construction. So just a little tape to hold the cap on here as we're grouting and pulling the probe rods out, just to make sure we keep the well protected and clean inside. You don't want to get grout inside your well. We've retracted approximately 4 feet, so now we should have some void space over the top of the screen, and we'll start pouring sand in there to build the sand barrier above the screens so that we separate any grout and sealants we put in the well from contact with the screen interval and the water that we want to sample. Again, protect the integrity and quality of the sample. Having the pre-packed screens lets you know exactly where the screen is at, exactly the place the filter media is at. You have the filter media all in place. One of the things to note here, there's no cuttings at the ground surface here, so we eliminate waste handling and exposure hazards and reduce the cost of installation. Actually, you can reduce the cost of installing the monitoring wells by from at least 10% to as much as 50% at some sites. We've already mixed some grout in the grout machine, and we prepared about a 20% solids bentonite slurry. We'll take the trimming tube, run it down in here, start the grout machine, and begin pumping grout in. We'll essentially fill the rods with grout so we have a good positive head of grout in the working rod string. You can see the hose kind of bump as the pump strokes, and I'll increase the engine throttle here so it'll run a little quicker for us. So what we're going to do is just allow the grout to start filling up the annular space between the rod and the PVC casing. So you can see some grout come out of the top of the rods. That way you know you have a full column of grout and you know you have good integrity seal. We'll continue pumping grout as we retract the probe rods. The steps and the procedure is very similar to conventional well construction. Primarily we're just using direct push methodology, small diameter tooling to accomplish this. We're at the bottom of the probe rod here. We've got grout coming out at the surface. So we have a full column of grout, good annular seal for the well. You can still see our grout hose is below the ground surface, so we stayed within the column of grout with the grout hose to make sure we got a good seal. And there's the end of our grout hose. Of course, if you install the monitoring well, one of the things you really need to do is development. What we have here is a 1-inch diameter pre-packed screen well with a flush mount well protector. What we're going to use here is a mechanical bladder pump, and this small diameter pump gives us the capability of conducting low flow purging and groundwater sampling in the small diameter wells, so you can meet the EPA requirements for low flow sampling protocol. Now we're going to use one of our check valves to show that you can use these for development of the well. Purging and surging kind of with the check valve will help flush fines through the screen and out of the system so you can get low turbidity sampling.